We have spent time solving many different types of equations. And now we're going to introduce something new, equations with radicals. So we're going to start simple and solve an equation that looks like this. The square root of x equals 11. We obviously want to get to a place in this equation where we just have x equals something. So we always try to think about this in terms of what's getting in our way, right? What are the things that we have to undo or remove or peel away from the x so we can just get down to this? And in this case, it's this radical. We need to get rid of a radical. And so that's saying the square root of x. We're going to do the opposite operation, which would be to square it. So when you want to remove a radical, you're going to square it. And then just like always, we're going to do the same to the other side of the equation as well. This square essentially removes this radical. So these cancel each other out. And all you're left with is x equals, and then whatever 11 squared is. And the answer to that is 121. Another one might look like this. The square root of y is equal to -3. So if you want to remove this radical, you're going to square it and then square the other side. When you square this radical, it cancels out and you're left with y equals, and -3 quantity squared is a +9. Now, you may have already noticed a problem with this. One of the things you always must do whenever you do this, squaring both sides of an equation, you always must check, spell properly, must check the solutions. Because sometimes you do everything mathematically correct, but one of the solutions might not work out. So we're going to take this first one and we're going to go back and check it. It was the square root of x is equal to 11. We're going to go back and check this. Let's substitute in our solution for x, the square root of 121. Is that equal to 11? And yes, the square root of 121 is 11. So this checks out. So that is a true statement. Now let's do the second one. It was the square root of y is equal to -3. If we substitute in our solution 9 for y, and then take the square root of that 9, we get 3 equals -3. And what you'll notice is that is not a true statement. So that means that 9 is not actually a solution. And we say that there are no real number solutions. There are no real number solutions to this second one. You may have even noticed this at the very beginning. When you saw the square root of y is equal to -3, you may have remembered that you can never take the square root of any number and get something negative. And so you might have recognized that right away. If you don't, no worries. You can still always check it at the end to see that it does not work. Now, sometimes these equations have a little more to them, like this. The square root of u minus 3 is equal to 6. So what we see here is that our radical has another term inside of it. But that doesn't change the way we do it. We're still going to square both sides of the equation. We will use the square to cancel out the radical, leaving us with u minus 3 equals 6 squared is 36. We add 3 to both sides and get u equals 39. We can check that solution by substituting 39 back in for u, 39 minus 3. And is that equal to 6? Well, the square root of 36 is equal to 6. So that does check out. So we have one solution of u equals 39. Let's do one more. 15 plus the square root of x plus 2 is equal to 8. So what we notice here is that we have a second term under the radical, but we also have another term outside on that left side of the equation, 15. You cannot square anything yet. You can't do this, squared, squared, squared. People try to do that all the time, does not work. You can't square the individual things. You've got to square it all, right? All or nothing at all. And this would require some really messy distribution. So what we do instead is we isolate this. We need to isolate the radical first. So we're going to subtract that 15 from both sides. The square root of x plus 2 is equal to 8 minus 15 is negative 7. Now we can square both sides. You may notice that there's a negative over here, so you may suspect that we get a solution that doesn't quite work. Let's try it anyhow. We're going to square both sides. Notice how I'm squaring just the radical, which cancels it out. X plus 2 is equal to. Now, if I square negative 7, I get a positive 49. I would then subtract 2 from both sides to get x equals 47. So let's check that. Let's go back to the original equation, 15 plus the square root of 47 plus 2 is equal to 8. If we subtract 15 from both sides, we get a negative 7 over here. And inside this radical, we can add those things and get 49. So I did a couple steps there at once. I combined these terms and I subtracted 15 from both sides. And just like before, we take the square root of 49 and get 7, and we can see that 7 is not equal to negative 7. That is not a true statement, which means there are no real number solutions. So this is going to be the main idea when we are solving equations with radicals in them. We square both sides to clear the radical once we've isolated it, and then we always have to go back and check to see that our solution worked.